Hello everyone, we are the team Vision Coders and I, Srushti Deshmukh as the team leader is here to present you the project of AutoHeal AI. This is a video demo of the project, but before that I want to give you a little overview about the project so that you understand what's happening on the dashboard. So AutoHeal AI is actually an autonomous IT incident remediation system, which is it detects the infrastructure problems and investigates them obviously, and then fixes them automatically without human intervention. Even though in certain cases there is human intervention, there is human approval needed when the fixes or when the alerts are really not something they are trained upon. Otherwise they actually are capable of fixing the alerts all by themselves. So just an overview about how is this happening. This is a pipeline, and this in the pipeline there we have simulated the monitoring systems of cloud monitoring systems like Datadog, CloudWatch, and then accordingly the alerts are fed into Kafka. After that, the Kafka has seven topics which takes the data forward through the pipeline. And then there is, after that we have BERT classifier, which classifies the alerts into 10 different categories. These categories are then can be confusing because each category can have a cascading loop. So we have introduced a dependency graph to enrich and find out which pattern or which a service is the root cause. And then we have used DBSCAN, which clusters the incidents together so that the in a window so that there is no flooding of alerts to the LLM. So for that way the efficiency of the LLM can be maintained, and also it can give us very efficient and very good results. Then we have used pgvectors, which is the historical which searches the historical incidents, which are the past incidents, past alerts, and then tries to find out the similarity. If it's above a certain threshold, then it applies those fixes which are already approved, and if it's not, then it goes to the LLM for approval for reasoning, and if not that, then it will be escalated to the human. So that's all how the alert system is maintained, alert system is done. It helps a lot of DevOps engineers, it helps a lot of people in the engineering field, in the IT sector, because you never know how much when a server can just get down and at midnight or at certain time of the hour. So it's very useful that AI automatically fixes AI automatically fixes things. And that's how our project aim was, to ease the job of an engineer, to ease the job of a DevOps engineer. So yeah, let's go to the dashboard. And in our dashboard, yeah, so this is our dashboard, and in our dashboard we have the active the active filters, the remediating filters. So all of our data, all of our alerts which are going to be counted by the monitoring tools would be filtered into these categories. So resolved, so these are the ones that are resolved earlier, and the one that I just added for investigating, this is the one. This is the remediating part. So this is the one that is getting invested so that it can get fixed. Then there are different topics in the sidebar. So incidents are there. This is the incident bar for the incidents, which is the main part. Then the health. Now there is a different timeline. There is different features in the pipeline. So like the dependency graph, the DBSCAN, all of these features. These the health of these features, or are they okay, or are they doing well, or these features are workable. This will be tracked by this part of the dashboard. So Olama 8B, Olama 70B is the rule based more active. So is there any circuit breaker? So the kind of these things, the Kafka topics, the pipeline of the Kafka, is it actually going well? The BERT classifier, which we fine tuned, so is it actually good enough? So these are the features that are these are the features that needs to be tracked. So that's why they will be in the health tab. Then the activity. Now I have added a certain alerts in this. Now they are getting resolved. So maybe certain type of alerts will not be shown in incidents. The one that are getting resolved already will be in the activity log. This is the log of every second. So every second of the cloud monitoring tools with the data they're sending them every second, or every time there is a alert, so that will be in the activity log. So even if there is any info, so that will be tracked by the activity log as well. The alert which are getting tracked, alert which are getting successfully fixed, they will be also shown in here. Then there will be info, the one that are escalated as in given to the humans. Now some alerts all the alerts can't be solved by AI. Some of them might be new, some of them they won't be trained on. So there is a human in the loop option feature here, in which the alert will be given to the human as well. Then the pipeline, this is just for the knowledge of the user that what happens behind the scenes. So there is a pipeline in which there is alert, BERT classifier, every single thing is being given here for the understanding of the user. Then there is LLM routing. How is the alert given to the router? How is the alert given to the LLM to solve? So on what basis? Then that's also there. And also again learning, this is the MTTR trend, which is the mean time taken to resolve. So before, how during the training, after the training, how much time it took to resolve the alerts, that's been shown by the graph. And also then there is a certain features like the timeline of a certain alert that can be tracked. So if there is a particular alert here, this one, so this one this particular alert, it's being tracked. So every single thing, the alert ingestion, the BERT classifier, these are to show the user how it's going on. This is actually included here. So that's all with the dashboard, the health, the pipeline, with everything. The LLM is being see again, it's being resolved here. And after being resolved, it will be shown in the resolved patterns here. So yeah, that's being done. The one that are still investigating, one that are escalated, these are active ones, so they haven't been resolved. You can just click on it and you can see that there is human approval needed, so it can approve and then it can be fixed. Again, the next one, they are remediating. That means it's the intermediate stage. LLM is still performing the actions. So yeah, the working is this is the prototype that we have that we have coded. And again, it has a scope of improvement, a lot of scope of improvement, but this is the basic prototype about the incident remediation system. Just an overview about the file structure. Now we have there are different file folders like common. This has something that has this has logging, which is obviously common to all of the features of all of the services. Then there's schemas for AutoHeal services like Kafka. Then in models there is the fine-tuned BERT classifier, which is again for efficiency. Then there is Rego, which is a OPA or open policy agent for LLM routing. Then scripts, this has something that is not in the dashboard. This is this is in the backend for increasing the efficiency of the services. Now like the seed dependency, seed incidents, this is fed into the PostgreSQL to increase the confidence level of the system. Then the requirement file, the Kafka topics, all of these are microservices and scripts that help to efficiently execute those services as well. Then the script controller, this is the one that shows the cascading failure. This is the one that starts the system. And once I run this file, that's when the alerts pop up on the dashboard, as you saw earlier. Then the stimulated environments of the CloudWatch and Datadog, all of these which are the monitoring tools. These are the ones that feed the alerts into the Kafka file, Kafka topics, and that's when it's moved forward into the pipeline. Then all of these services, again the dependency services, all of these have main.py files and docker files with requirements.txt as well. So all of the services are dockerized. Each and every one are containers, so that it is easy to scale and also maintain. And also again the services are dockerized, and also dashboard, when you see, is again dockerized as well. Again the Fling DBSCAN, the dashboard, this is dockerized as well. And we have used React plus TypeScript for this for this dashboard. This is very helpful for connecting to the backend. We have used Nginx along with Docker and start.sh to run these two architectures together, which helps to connect to the backend more easily rather than going through a long way. Then again package.json, all of that. So these are the Docker files that are these are the files that are there in the system, with a Docker compose file as well, a Docker compose that just binds all of this together. Then the BERT training CSV, the Docker file, this is the one that binds all of the containers together, all of the images together in a container. So yeah, that's it. SQL init, which has it has the scheme as a framework of the schema of the PostgreSQL, which we have used for storing all of the data. So that's it. Thank you so much. Thank you.